Alright, CNT125, Chapter 12, Layer 2 WAN technology. So let's take a look at frame relay. Frame relay, a group of Layer 2 protocols defined by ITU and ANSI, again in the mid-80s. Originally, it was a fast packet switch network over ISDN. Today, it's a downlink layer protocol for various virtual circuits and interfaces for WAN connection. The name, frame relay, data separated into variable length frames. This sounds a lot like, Ethernet, that kind of thing. That's kind of the idea. Relayed from one node to another without any verification or processing. So we're not reading all the headers like we did so much with Ethernet. Okay. Routers establish a permanent virtual circuit, and frames have identifiers, DLCs, DLCI, data link connection identifiers, DLCs. The routers read the DLCs and put it on the correct circuit for the frame. Once it's on there, we don't have them continually being read like we did IP packets or Ethernet packet or frames, if you will. And frame relay is a connection-oriented protocol. Once that's set up, all those frames are going to take that same path from A to B. So it's almost like it has its own circuit. Organizations might use frame relay for communication between LANs at each branch office. Each LAN has a permanent virtual circuit from the branch office to ISP. And then that pathway could connect branch to branch or branch back to the central office, if you will. Frame relay equipment consists of your DCE at the ISP's location and a DTE at the customer's location. And a frame relay capable router or switch might be just that piece of equipment, or they also have a frame relay access device. Here is a sample, main office, and here's branch. Okay, so my branch office might have a actual connection, like a router kind of deal, connecting into the frame relay switch network. And this frame relay switch network has a path laid out for me to connect to the main office, the central office, if you will, or the headquarters. Here's showing just maybe a little bit more detail, same idea, but a little bit more detail. The links between router to router. There is actually a DLC path, DLC circuit made up that it's almost like it's its own circuit, but it's really just the frames follow that same path from A to B, so it's like there's an actual circuit. And this gives you an idea of the configuration for these DLC paths. Okay. The book shows an example of 3 frame relay connections to the ISP create 2 different logical permanent virtual circuits. So we have branch office, main office. We literally have 3 connections to the ISP right there, boom, boom, boom. And then the pathway, the circuit made, the logical permanent virtual circuit made from here through the frame relay network to here makes one path, and the logical path from here through the frame relay network to here makes the second path. So you have your 2 branch offices connected back to the main office using a frame relay path, if you will. They're not dedicated, they're individual links. In that lease circuit, if you will, that circuit acts like a dedicated link. And you notice I'm saying acts like. All the frame relay frames follow that same path, so it's like you have that circuit. You're going to lease the frame relay circuit, and the contract is going to reflect the endpoints you need to connect, if you will, amount of bandwidth for those, and the service provider is going to guarantee a minimum amount of bandwidth for that link in the form of a CAR, committed information rate, for that link. I'm going to lease the PVC, and I share the bandwidth with other frame relay users, but I'm going to get that bandwidth that I have leased from them. The permanent virtual circuit links are best suited for frequent and consistent data transmissions. So again, connections between our 2 sites. Advantages: I'm only going to pay for what I need. It's less expensive than some of the other WAN technologies. Side note though, frame relay many times has been replaced by newer technologies that have come along. Once upon a time, I used to use a frame relay network to connect together different lab tables in a room for exercises we did. I no longer do it because other technologies have come along and replaced that. But I used to simulate that for different labs we did. Next layer 2 technology is ATM, asynchronous transfer mode. So let's take a look at this guy. Asynchronous transfer mode functions primarily at layer 2. ITU standard prescribes both network access and signal multiplexing techniques. Asynchronous in this example, or this technology, refers to communications method. Nodes do not have to conform to any predetermined scheme that specify timing of data transmissions. The nodes themselves can transmit at any time. The destination node must accept the transmission as it comes, almost very much like a IP packet moving through a network. I can submit it at any time. The receiver must accept that at any time it shows up. The contrast to this is something like our timed synchronous of Sonnet. Okay, so just to kind of recognize the difference between. For ATM, asynchronous communications, you have start and stop bits. So when I send something, I have a start bit to say, hey, start paying attention to the data here, and I have a stop bit saying, okay, no longer important data, don't worry about it. Okay, so the receiving node recognizes the start bit, begins to accept that new character or chunk of data. When the receiving node recognizes the stop bit, it's going to stop looking at that. And asynchronous data transmissions, ATM, occurs in random starts and stops, if you will. Here's a chunk, nothing. Here's a chunk, nothing. Okay. ATM specifies data link layer framing. It's going to use a fixed message size called a cell. The ATM cells are 53 bytes, fixed length. All ATM cells are 53 bytes. So that gives you 48 bytes of data and a 5-byte header. What this does, this fixed size cell, allows ATM to provide predictable network performance because everything is moving around as the same size. That's like, if you ever loaded a truck at a loading dock, all the boxes coming into the truck are the same size. That would make it so much quicker and easier to load the truck. And that's the idea behind the ATM fixed size cell. The downside is the smaller message size requires more overhead. It does increase the overhead, so it decreases the potential throughput. But the overall efficiency helps to compensate for that loss. Everything being the same size helps compensate that loss. It's going to rely on virtual circuits. The switches determine the optimal path from A to B. The virtual circuits provide circuit switching advantage like we have with our phone. It's a reliable, available connection. With this virtual circuits, it's like a connection-oriented technology, very much like a phone call. Connection made, transmit all the data, close it down. But it's still considered a packet switching because of that cell that we're moving through with the little bit of header. Okay, it's still considered a packet switching technology. It does allow quality of service because you can make a path from A to B. We can say, okay, we need this path from A to B because we need higher bandwidth because it's a piece of voice information. So that allows for a little bit of quality of service, better quality of service guarantee than other technologies. Here's example ATM router, ATM switch, ISP network, etc. ATM is relatively expensive. It's rarely used on LANs, almost never used to connect a workstation to a network. It was popular in the 90s, but it has been outshadowed by other technologies, overshadowed by IP and MPLS, but now it's being edged out by things like Metro Ethernet. So it's one of those, it's around, stick it in the back of your brain, you might see it, you might see it pop up, so at least familiarity is key. Last layer 2 technology is your MPLS, multi-protocol label switching. With multi-protocol label switching, this was standardized by IETF, Internet Engineering Task Force, in late 90s. Some strength of ATM while avoiding weaknesses. So it took some of the strengths of ATM but tried to avoid some of the weaknesses of ATM. And to do that, it combined circuit switching and packet switching. It's going to enable multiple layer 3 protocols over connection at layer 2. It's going to support IP and other layer 3 and higher protocols used on TCP/IP networks. It's a little bit more versatile. Can operate over Ethernet frames, more often used with other layer 2 protocols. So again, you're kind of noticing kind of the hand picking of different things in there to make it a little bit more usable. MPLS is most often used by ISPs on their network for moving traffic from customer to customer. Again, so getting this connections that the customer needs. It is becoming a solution for some enterprise-grade networks to connect their branch offices. You might actually see them using an MPLS connection between their branch offices. Benefit, ability to use packet switch technologies over traditional circuit switch networks. So I can take my packet switch data from my network, run it across the circuit switch network, and back to the other site. So this can create end-to-end paths, act very much like a circuit switch connection VPN from point to point. To do this, an MPLS label gets put in. So if I take a look, the first router receives a message in data stream. It's going to add a label to the layer 3 packet. So I have my layer 3 data here, an IP packet, if you will. An MPLS label gets shimmed in here. That's why they nickname it a shim. That's a label where it gets routed to, and then the layer 2 header gets added out here. So because that is getting placed between layer 2 and layer 3, it's sometimes called a layer 2.5. MPLS is layer 2.5. And then your network layer 2 header is added out here, as we said. MPLS labels, info about where the router should forward the message next, and sometimes a little bit about prioritization. Each router in the path stream revises the label to indicate the next hop along the way. And the routers on the network can factor in network congestion, quality of service, other metrics about the path that it's moving it through. The network engineers have control in setting these paths, so therefore MPLS offers potentially faster transmission, better quality of service. It's very well suited to WANs, and again, as they said here, almost like your WAN provider. Here's an MPLS network showing connections of different places from A to B, and your MPLS network is providing that for various customers. All right, we'll come back in some of our last WAN technologies.